Hello everyone, what a pleasure to be here at the Teams Conference 2022. I appreciate the invitation to this workshop and I sincerely hope you all find it interesting and learn something new to implement in your future IoT projects. Before starting, let me introduce myself. This is Johan Macias over here, developer advocate at Rad Wireless, where I'm essentially responsible for supporting our community and customers to take their IoT projects to the next level by addressing any technical concern or doubts about our RACS ecosystem. Over the last couple of years, Rad Wireless has continuously worked with its customers to drive further technologies that facilitate implementing IoT solutions. One of the key communities for the growth that the company has had so far has been the community we had formed from the Things Network. A community that, along with the professionals and enthusiasts of LoRaWAN technology, come together to solve problems in different industries and save resources, becoming something essential to constantly learn from the ecosystem and the implementation experience of each of our customers, allowing us to continually invest in a variety of products that make the Internet of Things truly easy. Perhaps some of you already know the company's motto is IoT made easy, which may sound a bit cliché, but in reality, it's becoming far from it. As I highlighted earlier, Red Wireless is known for being a hardware company. However, over the last few years, we have invested in driving software tools that, regardless of the hardware you are working with, you can count on tools that allow you to shorten the learning curve in both the technology and the ecosystem, as well as to ensure the efficiency of the solution being deployed. The industry needs to reduce the time to market. Moreover, there are more and more demands in different sectors, and in most of the cases, each has unique characteristics where something generic wouldn't be suitable. Nevertheless, considering these needs, RAC has been driving a complete technology ecosystem to enable a short adoption stage to reduce the implementation time to validate proofs of concept in just a couple of weeks, helping to get to market in the shortest time possible, to drive savings in resources, and to improve processes in the different industries. In this workshop, I will focus on two powerful software tools we have been preparing for you. Let's say you are starting your LoRaWAN journey, or maybe you have experience with LoRaWAN, but it's your first time with rack modules. For instance, a core module in our WISBlock ecosystem, like this one that I have over here. How could you configure this module to start sending data? First, let's go to the Things stack, Community Edition, and select this application that I have created over here. Go to the End Devices section. We are going to add a new end device. Select the brand. The model in this case is WISBlock Starter Kit. We can set the region as well. Let's use the recommended one here. We can left the application EUI field with zeros. The device we need to use the one that is printed on the module in this sticker. I'm going to paste it because I have it in my clipboard. We can generate the application key and press register end device. We created this device. Let's move to the live data section. In this live data section, we are going to start receiving some join requests to the network just when we configure the module itself. To configure the module itself, we are going to use one of the software tools that I said before that we are going to use in this workshop. That software tools is called with Toolbox. It's available for desktop and mobile. In this case, let's try the desktop version. I'm going to connect the module using an USB cable. I pressed connect device. It's checking for the port. It detected rack 4630. Let's press connect. Open the details of this device. If we go to the parameters section, we're going to find several options to configure the LoRaWAN parameters, and they are organized in a way that we can easily understand what parameter we need to modify. For example, in this case, from the Teams stack community edition, we are going to get the application key and the same device EUI we registered. The device EUI is the same that I have my clipboard, and the application key is the one that I can copy from here. If I paste over here, I can see a list of commands over here that are the commands that I have modified using with Toolbox. So I can apply these commands right now to modify the device AOE and modify the application key from the default values. If we look into the other parameters, the application EUI already was filled with zeros, so we don't need to modify that. Let's apply these parameters. Both of them were successful, so this tool can give us information about if the parameter I changed were valid, and if when requesting to the device to modify those parameters, if it were successful or not. We are ready to try to join the network. Toolbox also allows to join the network over here. And take a look over here, and we start to get in some live data over here. If we see all the activity, we can check that I received a join request and a join asset was sent to my device. If I go back to Toolbox, the device info, I will have this LoRaWAN status change because we already joined the network, and a new field is enabled to start sending some data to the network right over here in this auction that is already enabled for us because the device already joined the network. So let's try to send, for example, some bytes over here. Let's say that we are going to send in a random port, let's say the port 4, the bytes 32, 30, 32, 32, which stands for 2022. And let's keep an eye on the console over here to check the message that I'm going to send. It's properly received over here. So it's the same payload that I sent over there, and I got a notification that the message was confirmed. Let's send the same packet to receive a new message confirmation as well. The message was confirmed. This confirmation is right after the network server schedule the download with the confirmation, and we also have several other options to monitor this device. For example, if I go to this console, I will find uh, the 80 commands like a traditional command terminal connection. I can interact with this module, but this already have, for example, all the available commands that I can send to this device. For example, this one is for query the network status. If I get one, is because I already joined the network. If I get zero, is because I haven't joined to the network. In this case, I get this one over here. It's because we already joined the network. If we need to send another packet, we can also send it over here. Let's say, for example, 10, 20, 30, and press send. I got that packet over here, so um, I can manage basically most of the things that I can do with this module using this terminal as well. So let's close this terminal and restore the module to the factory settings because we wanted to continue playing with this module in a, in a bit using another alternative to setting up this device. As I mentioned before, WizToolbox also has a mobile version. The mobile version is available for iOS and Android devices, and the communication with the module will be over BLE. So we need to use a module that has BLE capabilities. In this case, this WizBlock core has BLE capabilities. So I disconnect from the computer and I'm going to connect a rechargeable battery to it. So we can start connected to it using the cell phone. I'm going to press select device. I have two options over here. The sensor have it will be a new product that we will have in the future. So I'm not going to reveal so many details about it here. I'm going to select WizDuo LP1 module. I'm going to connect to the module. Is searching for devices. Is just this connection is only available after a reset on the module. So I quickly press the reset button and I'm going to connect right now. This data synchronization step is where the device is sending the information to the mobile application in order to visualize the same parameters that we had in the stock version. So we have the device information, um, parameter section as well. The global settings already have the network mode selected as LoRaWAN and the region that we are currently using. So we will need to modify the two parameters that we modified in the desktop version. That will be the application key. I can paste it because I already have it on my clipboard previously. This time for the device AOE, I can use the built-in feature to scan the QR code that is on the module. So I'm going to do that. And we are ready to apply those two commands to modify those two parameters. Apply to device, both of them were applied successfully. So I can close this screen and we are ready to join the network. So let's have an eye on the things as a communication console, because I'm going to press join network right now. The message is sent as the notification I get over here, and a new join request was received, and the device received a join asset. This notification join network appeared on the application as well, similar that we had in the stock version. So we also have over here the option to open a terminal console. The terminal console also has the available commands for this module. The network status is one, which means we already joined the network. I can also send a packet over here. Let's say it's 4 in the port 4. The bytes 1, 2, 3, 4, 5, 6. An easy packet this time. Let's press send. The message was confirmed. Let's see, open here all the activity, and we got the same payload that we sent. 1, 2, 3, 4, 5, 6. So I can close this console over here. And that's it. We already configured our device using the stock version of Quiz Toolbox and the mobile version of Quiz Toolbox. RUI 3 is the underlying software tool that allows Quiz Toolbox to work. RUI stands for Red Wireless Unified Interface. Version 3 is our most recent and powerful one. It allows you to create your own custom firmware by using a set of APIs. Those APIs are described in detail in our documentation center. At this moment, we can focus on example code that is written using RUI3. So the structure of this code is really similar to the one that you can find for Arduino sketches, because the RUI3 implements an Arduino IDE API. So that's the reason why you can find over here a serial methods from serial, methods to call wire, and all the similar things that you can find when you are programming in Arduino environment. The other API in RUI3 is the LoRaWAN API. This allows, for example, to set the ADR, the number of retries that the device will try to join the network, the message confirmation settings, and in this case, this firmware is intended to get data from an environmental sensor. So the variables to measure are temperature, humidity, and pressure, and they will be sent over the LoRaWAN network in this way. So every time the the period is complete, the device will try to send a new packet. This period is set to be 30 seconds in this case. So every 30 seconds, the device will try to send the message calling the uplink routine, and then it will call the system API to sleep in order to save battery when it's not performing the uplink routine. I mean, sending the message. We can compile and upload our firmware directly from the Arduino IDE. It's useful when we are developing the firmware. However, if our firmware is ready to deploy, as it is in this case, we can take the package generated by the Arduino IDE and upload it using WizToolbox. That's one of the extra features that WizToolbox has. But first, we will to execute that firmware on our device. I connected um, the environmental sensor in the base that I have the WizBlock cord in order to be able to read those variables over there. So I'm going to connect the device. Again, connect, and go to the firmware section. This official firmware, it's the same that you get when firmware from factory, let's say. And the custom firmware is the section that we are going to use for uploading our code. Let's set the upgraded option. It will take a few minutes or seconds sometime, depending on the size of that file, and all that is performed over the USB connection. And if we were using the mobile version, we also have all, that option over there. In that case, it will be performed also using BLE, in which it's called DFU over BLE. So let's wait the confirmation. Firmware update successful. We can close this window now. Let's go to Advanced, Open Console, and while we get some logs in this console, let's take a look at the other console in the Things Stuff Community Edition. At this moment, we already have a join request and a join asset log over here. So our device already tried to join the network, and we are just waiting the 30 seconds to get one of the readings of the sensor. Let's wait a bit for that. Here we have the readings, temperature, humidity, and pressure. These are the bytes that the device is sending for this message. We can check those ones in the console as well. These are in 01, 0A. Let's copy to clipboard to watch them over here. And they end on 4A and E6. So it's the same packet that the device generates. So it's working really good. UI3 is compatible with the modules listed over here. And one of the cool features of RUI3 is that the firmware you developed, I mean this code, can be deployed to different rack modules in this list. What it means that, for instance, I've been using this Wiswap cord, but I also compiled this firmware for the rack 32, for the rack 3172, and I'm going to connect it. To connect that device at this moment is the device that I have over here. I'm using a breakout board in upper the board to connect this sensor. So I'm going to connect to the computer right now, and in that way we can also connect another device on Whistlebox, which is means that we connect multiple devices at the same time. Connect. This is the rack 3172 that I just connect. Let's take a look quickly to the parameters. Is the same options that we had for the other module. This one has a different set of credentials that are registered in advance in this console. Is this one, and it has some activity recently because immediately I connected to the computer, it started to execute the firmware that it does the same that the other firmware that we have in the other device. So let's take a look at it as well. We haven't talked about downlink messages yet. Every downlink sent from the network server is also processed as an event within Toolbox. So let's try that. Downlink, let's say to port 3, and the payload at 555555. Let's schedule the downlink, and let's wait for a few seconds for the next upload message. Right after that, we must receive our downlink message. And the live data. So we receive our set of files. Last but not least, every set of parameters that we have for our modules can be saved as a template. The template feature of this toolbox will allow us to save and storage those parameters locally in this computer or in the cloud using the rack ID. Imagine the rack ID is something similar to the concept of the Apple ID. It's an account to start and synchronize settings across the different software tools that rack offers. This to continue making IoT easy. So I hope you enjoyed this workshop, and if you have questions, I will be over here on the chat when this recording finished, and you can also contact me anytime, or our Rad Wireless support team members in order to address any questions that you may have about the software tools that I talk in this workshop. Thank you so much for attending.